Hello friends, welcome back. We are making a Lisp and we're on step 4 still. This is going to be the third video about step 4. We're going to finish it. We're so close. We're so close. We just have 16 failing tests here and yeah, I feel confident that we can do it. We've got some issues with PR, stir, and PRN. I feel like they're probably all related in some way because they're all dealing with strings and escape characters and stuff like that. What makes it a little bit hard, as you might recall, is the escaping. When the tests fail and it prints out the result, it's a little hard to see exactly what it expected. And so I think maybe this top line is the best indication here. So if we run, let's make sure, there we go. Let's make sure that we can see what this is doing. It's not interpreting, is that what it is? It's not interpreting the backslash characters when we parse the string. So I think in order to see exactly what we're dealing with here, I need to present the backslash the way I would expect to see it after dealing with Ruby and pretty much every other language. Is when we're printing the string, if we see that backslash, then that means it's an escaped backslash, and that means we need to put 2 backslashes. I think. Does that sound right? Let's try that again. As you might recall, I have an issue where it doesn't recompile everything if I only touch one of the headers. And I think I just need to tweak the make file possibly. And I'm not sure exactly how to do that, but I will work on that at some point. So if I do this, now we're getting kind of what we'd expect. This is wrong. This is supposed to be just a /n by itself. So I think what we need to do on the Lexer, is it on the Lexer? Reader, CPP. When we do a new string, how are we going to do this? This will be the raw string, right? The raw string. We need a way to pass in. Actually, no. Let's pull this out. Say this is stir, auto stir equals this, and auto string processed. And then we'll loop over the character, sort of like this. We'll do the same sort of thing here, but in reverse. So stir. So if it's a double quote, then we'll call this processed. If it is a backslash, so we can't really do it like this. So size t, actually, just had an idea. We don't need to do that. I is less than token dot size -1, and then auto c is token like so. Unused variable C, switch on the C, misleading indentation. Oh, that's right. Let's fix that. Okay, so if we see a double quote, we're going to append a backslash and then the double quote. If we see a backslash, then we're going to assert that I is less than size -2 because we don't want to be past the, so if we have this, we have foo backslash, sort of like this, then we want to make sure that I 0, 1, 2, 3. So the backslash character was at character 3. We want to make sure that we're not here, which would be -1. Maybe I'm confusing myself. So let's put this back like it was. It was actually easier when it was a substring, I think. And then we'll do it this way, and we'll start at 0. Yes. And this will be stir size. Auto C is stir I. Okay. So back to here. If we see a backslash, then we want to do ++I and assert that it is still less than the stir size. Because if it's the stir size or more, then that means we went past the end. And now we want to say C is stir I, and we want to switch on this. Switch on this C. Case if it's an N, then process, we want to append a real \n, a new line, a real new line. Break. If it's, well, that's fine for now. Anything else, we'll just do processed plus the actual character. We don't need the break. Okay, does that kind of make sense? Switch case break processed. Okay, so it would be cool if we could move this out into its own function. Return. What method are we in? We're in read form. We'll do read string token, and we'll move all this to read string because we have value read integer. We'll do read string, reader, and reader. And I guess we just pass the reader here. And auto token is reader next. Boom. Okay, so token.size. We'll do value here because it should not be. We know it's there. We know how we have a real. It's not optional. I mean, it's there. It's there. We know it's there. Words are hard. Reader. Use of undeclared read string. Oh, right. Reader HPP, read integer, read string. So let's just remove the space on all these. Ooh, read stir. No way. What is that? Oh, that's like the top level. That's like the top level thing. Okay, that's a little bit confusing. Read with meta, read list, read vector, read hash map, read atom. Okay. I think, and then this can be off by itself. So these are kind of like underlings. I probably should have created an object, like a class for this, but it's okay. So our little reader is getting bigger. Read string. Let's see if that even compiles. So if I say foo, that compiles. If I say foo \n, it interpreted that as a literal backslash followed by a literal n, not a new line. So what happened here? let's print out the stir. Printf actually stood C out. Stir equals yeah. Okay, that's what we expected. Those are the literal characters. Literally FOO, a literal backslash, a literal N. So the error is somewhere in here when we see this backslash. What are we doing? What are we doing wrong? What are we doing wrong? So or C is I don't need that one. We'll say backslash and then N is a little bit dumb, but I think it'll help me make sure that I'm actually getting inside of this case. Something tells me I'm not. I am getting inside of it. Okay. Cool. So everything is working like we expected in terms of this code. So let's look. Oh, processed. There it is. There it is. So yeah, it actually worked exactly like we expected. We just didn't pass it into the string object. It's okay. We didn't waste too much time on that. Very good. Now, on the way out, we have to handle it as well. On here, if we see a backslash n, then we need to append a backslash followed by an n. I think that's right. It's kind of brain bending to deal with character escapes, and kind of hurts a little. Okay. 8 failing tasks. Look at them though; they're all print line, which we haven't implemented yet. So print line not found. We just need to go figure out what does print line do and implement it. Print line. So we're going to add this baby. We're going to go to our core file. We'll put it, I guess, right here. Oh my goodness, that's not it. Put it right there. Copy. It's probably going to look a lot like that one. So print line calls PRStir on each argument with print readably set to false, joins the result with space, prints the string to the screen, and then returns nil. Okay, very good. If the arguments are 0, then probably just do stood cout new line. I'm just guessing. Return a new nil value. Missing that. And then otherwise, print readably set to false, joins the result with spaces. Okay, it's going to look a lot like this. This is going to be set to false. It's going to be joined with spaces. We're going to print it, cout stir, and then return a new nil value. So we need to add print line here. Print line. And then core HPP needs it as well. Print line. And did I remember to do everything? I don't know. Let's run the test suite and see what happens. 0 failing tests. Boom. Ah, that's so good. Yes, we did it. Took 3 videos, 3 sessions. Oh, but we got it. That was the big one. That was the big one. All the tests are passing. Well, since that didn't take too long, we're going to do one of the things I've been wanting to do, which is in types, HPP, types. Oh, I'm in types. Yeah. We're going to make false, which is the first one here, private. I think you can do, is it static inline or inline static? I don't remember. I think it's inline static, false value star the, let's just call it instance, and we'll call it static instance, and something like that. And then over in types CPP, false value, is that the only one we have? That's the only one we have. Yeah, so here I want to do static the, which will say static false value star, which will say if s instance, then return s instance. We'll say if not s instance, then we're going to say s instance is new false value, and then return s instance. Something like that. Is that how you do the singleton pattern? Possibly. I might have done that slightly wrong. Does it matter on this? Static inline doesn't seem to matter. Which one makes more sense? Static inline or inline static? Yeah, I don't know. So let's do that for nil as well. We'll say nil value, and we'll copy this and nil value. Okay, and then true value. True value is like a hardware store, I think. I think there's a hardware store called True Value. It's kind of funny. True value. This is going to be true value as well. Okay. Yeah, so we got true value, false value has its own inline, and then nil value has its own inline, static, singleton. I think the reason you need inline here is something with like C++ 17 or I think one of the versions added the, so used to you couldn't do this, you'd have to do it like that, and then in the CPP file you could set it to null putter, but I think if you add inline then it lets you set it to null putter. If I remember right, but we'll find out. I'm sure the compiler will yell at me if I did something wrong. Let's just see if it even compiles, because I shouldn't have made any breaking change. It does compile, but now I'm going to make a breaking change. So let's add everything to the index because everything is working. Let us make the constructor private. Yeah, false value, same thing with false value. It's going to have a private constructor, and true value, it's going to have a private constructor. Now, that should definitely break the build. No, it did not, of course. Touch. Yes, is private within this context. So everywhere I do, let's do new, false, or true, or nil, value. Everywhere I do that, we're going to say return true value the, return false value, the. Probably should call it instance or something. I don't know. I just like the or the. I don't know. I'm from Oklahoma, so we say the. No typed name the and false value. Oh, it's not new. Okay, so this seems like a job for sed, right? Sed in place, substitute new false value for false value the globally. I think you do that way. Star.cpp, star.hpp. And then we'll also do true value and nil value. So did it, yeah, seems like maybe that worked. I guess we'll find out when we compile everything again. No, expected. Oh, because I have some of those. That's fine. I have that bad habit of doing the empty curly braces. Step 4, 52. Step 4, CPP 52. We just need to get rid of that. And then the other one was reader CPP 59. Reader 62, 65, that's where I am. Okay, so let's see if that fixed it. False. No. Didn't work. Did not work. I probably did that wrong. Did I get static and inline backwards? That's the question. Oh, run. False. Yeah. Oh, the. It's just a stack issue? Fascinating. Okay. What did I do wrong? Oh, I accidentally changed this with sed. Well, that happens sometimes. New nil value, and then this is new true value. Yes, that makes perfect sense. And I don't know how I did that. I did a semicolon. Sometimes I just need to slow down. Sometimes we just need to take a second and type the right code. False. Oh, run. False, nil, true, truth is not found. X, or def x1, x. Okay, that seems to be working. Let's make sure all the tests still pass. They do. Oh, that feels so much better to not have duplicates of nil and false and true. They should always be the same. Oh, does that mean the operator can be simplified? I'll just say look at this. You know what we could do? We could say, by default, just return whether it's literally the same pointer. And then we could get rid of this because it's a singleton, always going to be the same pointer. We don't need that. And nil value, don't need that. Let's make sure those tests pass. Boom. Ah, feels good. Okay, so I think that we had an issue with the previous tests. Step 3 tests were failing because we made changes to those shared files. And that's one thing that just happens with Mal, I've noticed. And you have to decide whether you want to go back and tweak the old steps which I think I've always chosen to do because I just want all the tests to pass if possible. Even the old steps we're kind of done with it. But that also means it's not representative of the work you did at that time. So you can't go back to step 3. So if I go make changes to step 3 to make and compile, then it no longer represents what I did back then on step 3. And it's just a trade-off you can make. So let's just go through and see if we can get this fixed. So step 3 EMV 152. Oops. Right here, it does not like the div, just like the newer code didn't. You know, it really makes me wonder, what is that? Turns the integral quotient and remainder for the division of number. I mean, I guess I should have known that. Yeah, so you just can't have something called div. Of course not. Why is that not? I guess that's part of the C standard library. Maybe I imported something. Don't know. It doesn't matter. We'll just call it divide. And we can then make one little commit that fixes it, potentially. Hey, that does work. Okay. So maybe I'll make it as a separate commit. Step 2. Same problem, I believe. Step 2 eval CPP, divide. So this is not Mal's fault. This is just purely my fault. Now this is different. This needs to be fixed. So when we are printing stuff, PRSTR here, we need to say print readably true. So that was a deferrable test I did not do back in step 2, which I should have. So is step 1 passing as well? No, of course not. End of input. It's supposed to say end of input. Okay, we'll work on that. So reader, CPP, read, string. So here, instead of the assert, we're going to say throw new exception value. What was it called? End of input. Say if token size is less than or equal to is less than 2. Then we're going to throw that. Step 2, we're on step 2, right? No, we're on step 1. If I just do a quote, terminate called after throwing an instance of exception value. Oh, because we didn't start rescuing exceptions. This is just going to be the commit where we just go back and alter history, I guess. Step 4, how do we do that? Catch, we have a catch here. It's in rep, so we're going to do try catch. Just going to copy all that. And here's another assert. We say if size, then say unbalanced, I guess. unbalanced quotes. Does it matter what exactly it says? I think it can just match any of those. Okay, 39 failing tests. Because of what? The way I was parsing strings? Did I... So here's what happened. I wasn't parsing strings before. They were just being interpreted as a symbol, as a literal sequence of characters. Well, when it printed out that symbol, it matched what the test expected. But now that we have real string parsing, these are failing. And so I guess this is a good reason to go back and make all the tests pass on every step. Because I deferred and didn't implement string parsing, I now need these tests to make sure I do it right. Okay, all that said, this one failed. I don't think we're going to be too far as long as I just hit a couple of these. I think the other ones will happen automatically. It's supposed to be a backslash quote. So over on types, CPP, string value, inspect. Did I leave it in the header? Let's get rid of that in the header because it's going to get big. Yeah, I left it. Oh, it's big. It's already big. Okay, that goes over here. String value. Don't need that. Don't need that. Move that over there. Delete. Not sure what I just did. Delete that. Something over here needs to change. So if we see a quote, then we're supposed to, oh, we're already doing this. Then we're supposed to add a backslash. Oh, that's if it's readably. Oh, yes. Perfect. Step 1, CPP. I gotcha. Over here, this is supposed to be print readably. PR stir true. Let's just do it on step 2, CPP as well. We already did that. Step 3, CPP, PR stir. Let's do it on all of these. Step 4, PR stir. Yes. Step 1. Oops. We did that. Save. Step 0, CPP, and this one does not call PR stir. Okay. Hopefully that's it. No. Oh, think that I don't have the default here, right? Two failing tests. Oh, and it's that blasted minus thing. It's supposed to be minus ABC. Fascinating. So if I put this symbol in a REPL, then I get negative 154. Cool. That's fun. So that's in our reader CPP. Let's just find that. Negative true, read integer. So we're calling read integer on something that we shouldn't. So if the next token we don't need to peek this because this is literally just token. if the token length is 1, then we're going to read the atom. Otherwise, we're going to read an integer. Okay. So this is an OR. If the second character is not is digit, then we will also read it as an atom. Make step 1 read. Oh, nothing to do. Oh, that's why. There we go. So ABC minus 1, 2, 3, 4. Ah, cool, cool, cool. Step 1 should all pass. Step 0 should all pass. Step 2 should all pass. Step 3 should all pass. And step 4. Okay. We did it. Oh, step 5, tail call optimization. This one's so fun. It hurts my brain, but it's gonna be fun. Okay, cool. Well, let's add the stuff that fixes the shared code. Let's add all that to this commit. Unbalanced quotes. That one's an old step, old step, old step. I'll just do none of the file, none of that file. Yes, yes, and we'll say this is step 4. Step 4. Add if, fn, and do. Oh. Oh, it's so cool. It's so cool. I mean, do we really write 1,100 lines? No wonder it took 3 sessions. I mean, it's 1,100 line diff, so it's like half that in terms of actual lines touched, probably. But I mean, there's a lot of pluses here. Yeah, I'm not super thrilled with the const versions of the static casts and then the non-const versions. If you know a trick, like, how am I misusing const? Or is that totally normal? Is it normal to have 2 copies of the same method, one with const, one without? Or is that like an anti-pattern? Someone let me know in the comments. But anyway, I still feel really good about this. I think this was a good chunk of work. We fixed some bugs. We now have... Oh, I think I can delete that. Comment. Where was that? I mean, those are probably okay. Okay, so that was in core header. We'll get back to that in a second. So let's save that. Let's go to core HPP. Let's get rid of these. Let's do that. Let's add that back. Core. We'll amend the commit, save it, and then the rest is just cleanup of previous steps. Fix some bugs that popped up in old steps. Yeah, I think I think that's fine. It kind of ruins my commit history a little bit because I have step 1, step 2, step 3, step 4, and then I have this dumb one by itself. But what are you going to do, really? What are you going to do? Just one more time. Oh, feels good. Feels good, doesn't it? Are you working on something? Do you have a side project? Let me know. I mean, if it's something that you're excited about, I'd like to see it. You know, put it on GitHub or put it in a gist or something. Yeah, share it. And I guess that's the end of this video. So let's push that to GitHub, and the next video is tail call optimization, which will let us get away with doing recursion in a way that won't blow the stack. And that is a really important part of most Lisps. And it's even required in some, like Scheme. It's not a scheme unless you do tail call optimization. So it's not really an optimization. It's a requirement. But anyway, thanks for hanging out. I hope that you learned something, or I hope that you saw something interesting, and I hope that you have a side project that you're working on. And I guess I'll see you in the next video.